So we're starting chapter 10, okay? Chapter 10 from your textbook, trigonometry. I believe the basics are already done in class 9, slightly. I don't know if the class was done or not. But whatever you have learned in class 9, it will be repeated here, no need to worry. First of all, let's try to understand the meaning of trigonometry, okay? Trigonometry consists of three parts actually. Trigonia and metron. So we combine these three words and then we obtain the trigonometry. Three means three, and this gonia means angle, and this metron means measure. So basically, what trigonometry means is three angle measure. So where does the three angle appear? Triangle appears in case of plane figures. It appears mostly in triangles, right? So as a basic for your class 10, we are going to deal with trigonometry based on a right angle triangle. No other triangle for you. You just need to understand a right angle triangle. So if I take a right angle triangle, you know what a right angle triangle is, right? A triangle in which one of the angle is how much? 90 degree. So I have got a right angle triangle here. This is the 90 degree. So we will call this as the right angle. Okay, let's mark it properly. All right. Let's name the vertex, the points. These points we will name them. This is A, this is B, this is C. How many angles do you see? We have got 1, 2, 3. Of course, out of the one of them is 90 degree already. The remaining two, it can be any value. It can be 30, 45, 60. If this is 30 degree, then the other one will be 60 degree because the sum of all the total will be 180, right? If I've got 40 here, the other one will be 50. If this is 75, this one will be 15. The sum of 1, 2, 3, they should all be 180. So these are just markers. Don't focus here, okay? These are so that I'm just writing them down so that I don't forget what I'm supposed to teach today. Out of the three sides here, which one is the longest? Obviously, this is the longest, right? Longest side. If you look closely, what you're going to see is the longest side is just opposite to 90 degree. The side opposite to angle C is this side, right? For angle A, the side opposite is this side right here, BC. The side opposite to this angle B is this side right here, AC. So this, the longest side in the right angle triangle is opposite to the right angle. So we will give this a name. This longest side is opposite to what? Right angle. We will give it a name. This side is called as hypotenuse. Okay. So inside a bracket, I will write hypotenuse. These are a little bit new concept. The trigonometry is a new concept. This hypotenuse, right, as right side you have already learned. But trigonometry is a new concept. That's why I'm teaching it very slowly. Okay. Let me try to ease you into it. So if this is the longest side, the remaining two sides here, the AB and BC, AB and BC, these two sides make the 90 degree. So for a right angle triangle, the sides making the right angle is angle B, right? So this AB and this BC, these two sides, we will call them as right sides. So whenever you draw a right angle triangle, we will have two kinds of sides. The longest one is called the hypotenuse. The remaining two, we will call them as right sides. So forget this. What you need to understand is where is the hypotenuse from? Hypotenuse is opposite to 90 degree. Just understand it, okay? You might get confused if I draw the right angle triangle like this. What about this? If this is 90 degree, you might get confused which one is the hypotenuse. What you have to do is you just need to look opposite to the 90 degree. This is the hypotenuse. You will see in the chapter of triangles also, they will put the right angle triangles like this. If you put like this, then you just understand just by seeing here, this is a right angle triangle because 90 degree is visible clearly. But in case of this one, you might not think that this is a 90 degree. So you should see where the hypotenuse is based on where is the longest side and where is the 90 degree. Okay. Okay, now these two right sides, this right side AB and right side BC, we can differentiate them. We can classify them into two types. Who's turning on the microphone? I get frightened. So these two right sides, we can classify them into two kinds. Take an angle, not the 90-degree, but one of the angle. Let's say I take A or C, your choice. But for me, let me take the angle C. If I take this angle C, and let me name the angle C as theta. Theta just represent, theta is just like X. What does X represent? X represents something unknown, right? X represents something unknown. Theta represents an unknown angle. So in that sense, X and theta, they are similar. So you just have to consider that theta is an unknown angle. Theta can be any value. We're just putting in theta there because we don't know the value of the angle in this one. So based on this angle theta right here, the side that is exactly opposite to this angle theta. The side that is opposite to this angle theta, we will call it as opposite side. All right. So I'm writing this as opposite side. And the side that is next to the angle theta, this side right here. This side is also next to the angle theta, but we are not considering it because this AC has a particular name. It has a specific name. We call it as the hypotenuse, right? But the other one, the other side that is next to the angle theta, we will call this as adjacent side. What's the remaining one? The longest one. The longest one, as we have already learned, this is called hypotenuse, right? So if I take an angle theta here, the side opposite is called opposite side. The side next to it is called as adjacent side. What if I change the angle theta? What if I take angle A as the angle theta instead of angle C? What will happen then? What is going to happen is, let me redraw the triangle. So this is A, this is B, this is C. If I take angle A is theta instead. We took angle C as theta in the previous one, right? AC, it will still remain the same. AC will still be the hypotenuse. But what about the opposite and adjacent? Which one is opposite, which one is adjacent is not fixed. What you have to determine is based on where you take the angle. Where do you take the angle? If I take the angle here, the opposite is this one, adjacent is this one. But if I take this as the angle, then what's the opposite side now? This will be the opposite side. And what's the adjacent? The next one is the adjacent. So where is adjacent, where is opposite? It all depends on where you take the angle. Okay. So for better understanding, you better draw this diagram right now. Just do it quickly. Opposite, hypotenuse, adjacent. I'm rubbing off the other one. So this part is done. Right angle, triangle, and its anatomy. This part is done. Don't focus on here. This is just for my sake, not yours. Okay, now you copy meanwhile I'm when I'm writing. Okay, just stop for a minute. Next, let's come to something called trigonometric ratios. Trigonometric ratios. We have 6 kinds of ratios. We have got 6 kinds of ratios. We will say 6 types of ratios. The 6 types are called by these names. One is sine, next one is cosine. The third one is called tangent. Fourth one is called as cosecant. Fifth one is called secant. And the last and the sixth one, we call it as cotangent. Okay. I'm taking off this portion right here. I'm rubbing this off. So this sign right here, it is represented in short as sin. Don't read it as sin. This is called sine. Similar pronunciation with this one. This we say sine, right? So this is called sine. In short, we will write it as sine. This cosine, we will write in short as cos. Tangent, we write it in short as tan. Cosecant, we write in short as cosec. Secant, we write in short as sec. Cotangent, we write in short as cot. Okay, so you can write it down. You can make a little note there. The types of ratio, the sign is written as like this. Okay, so what you have to remember is sine, cos, tan, cosec, sec, cot. But for the sake of easiness, in order to make it easier for you, what you need to do is you need to remember only the first three in that specific order. Okay, sine, cos, tan. You have to remember like this. The cosec, sec, and cot, I will teach them later on. What I'm going to teach you is I will teach you what is sine, what is cos, what is tan. I cannot write sine alone. I cannot write sine alone, but the sine is to be followed with an angle. So here we have got how many angles right here? We have got A, B, C. There are three of them. Accepting this 90-degree, you can take any of this angle, either angle A or angle C. I can write sine angle C. I can write here sine of angle A, sine of angle C, sine of angle B. These are meaningful. But if you just write sine, this is meaningless. Similarly, if you write just quad, this is meaningless. Sine of what? It will ask sine of what? So yeah, if I take this, okay, this one I'm rubbing this off completely, no need for this. So in this right angle triangle right here, ABC, if I take this angle C as angle theta, then what will happen to sine theta? What is the meaning of sine theta? The meaning of sine theta is, what did we say? The sine, these are called trigonometric ratio. Ratio means we have to divide two things. What are those two things? Those two things are, in case of sine, the two things should be opposite side and hypotenuse. If I divide the opposite side of a given angle and the hypotenuse, the ratio that I'm getting, that is called as sine of that angle. So if I take this angle theta right here, the opposite side is this one, the adjacent, the hypotenuse is this one. If I divide these two, then the value that I'm getting is called as sine theta. So the formula for sine theta is opposite divided by hypotenuse. Okay, what about cos theta? Cos theta is the hypotenuse will remain the same, but the numerator, it won't be opposite anymore. We will have adjacent here. And the other one, tan theta will be opposite divided by adjacent. Okay, what are we doing is, first of all, you take a right angle triangle. We take a right angle triangle right here, A, B, C, and we take one of the angle as theta. You can take this one also if you like. Then based on this angle theta, we have got three kinds of side, the opposite one, the adjacent one, and the hypotenuse. Hypotenuse remains the same, but opposite and adjacent, it depends on where the angle is. If I divide the opposite side and hypotenuse, then we got what we call it as sine theta. If I divide the adjacent side and hypotenuse, we got what is called as cos theta. If I divide opposite side and adjacent side, we get what is called as tan theta. What about the rest then? The remaining. The remaining, this cosec, sec, cot, they are just the reciprocal. Reciprocal means if there is 1 by 2, you have to if there is 2 by 3, you have to interchange into 3 by 2. Reciprocal of what? Cosec is the reciprocal of sine, second is the reciprocal of cos, cot is the reciprocal of tan. So if I write the formula on the side, let me continue here, okay? Let me continue. Let me take this away a little bit on the side. What's the next one? We have done sine. You focus on the my highlighting part right here. We have done cosine here. We know the definition of tangent also. What about this cosecant or the cosec? Cosec is the reciprocal of sine. That means if I write cosec theta here, we're going to write the reciprocal of sine. What happened in sine? The formula for sine is opposite by hypotenuse. Write it upside down. Put hypotenuse above, opposite side down. So it will look like this. Hypotenuse divided by opposite side. You should know that this sine theta and this cosec theta, they are reciprocal of each other. Okay. What is above is below here. What is below is above here. What about the remaining secant and cotangent? Sec is the reciprocal of cosine. Cot is the reciprocal of tan. So just write down the formula on the side. Sec theta will be, you write the reciprocal of cos. The reciprocal of cos will be hypotenuse divided by adjacent. What about the last one, cot theta? cot theta will be adjacent by opposite. You can remember these three later. The ones that I'm writing in blue, you can remember these three later on. The absolute necessity for now, it will be sine theta, cos theta, and tan theta. What are the formulas for that? Just copy them down. Okay, 1, 2, 3, 4, 5, 6. So if you find it difficult in order to remember this, most of you will. Okay, even I did in class 8, 9. So sine theta, cos theta, tan theta. The first three. The remaining, you can just remember it by knowing them as the reciprocal. Sec and cosec are reciprocal. Cos and sec are reciprocal. Tan and cot are reciprocal. So if you understand the first three, sine theta, cos theta, and tan theta, it is very easy to remember the rest. So keeping that in mind, in order to remember the first three, you can use a very simple sentence. You remember like this: some of our children are having trouble over algebra. How is this helpful? Some of her children are having trouble over algebra. What you are supposed to do is you are supposed to take only the starting letters of each of the words. Some starts with S, off starts with O, H starts with H, her starts with H. So you can think the formula like this: X represents sine theta, O represents opposite, which will come first, H represents hypotenuse, which will be denominator. So these first three words right here, it will represent the formula for sine theta. Okay. So sine theta is from here, just by looking at her, of and the her, we will have opposite divided by hypotenuse. So let me just encircle them. This is for sine. And this remaining three, the middle three, children are having, you take the starting letter for each of the word also similarly. Children is C, R is A, having is H. So this is for the formula for cos. Cos is, cos theta is, A represents adjacent, H represents hypotenuse. The cos theta formula is adjacent by hypotenuse, CAH. You can remember from this part of the word children are having. What about the remaining? What about the remaining? These three, what does they represent? Trouble starts with T, over starts with O, algebra starts with A. So T, it will represent tan theta. O, it will represent opposite. A, it will represent adjacent. Tan theta formula is opposite divided by adjacent. You have to follow the specific exact order. The trouble over algebra TOA. So tan comes first, opposite comes next, adjacent comes last. Same here, sum of her case also. Sum S represents sine, O represents opposite, H represents hypotenuse. All right, so the trouble over algebra part, it will give you the formula for tan theta. Sum of her part, it will give you the formula for sine theta. Children are having, it will give you the formula for cos theta. And remember, you have to take only the starting letters only. The letters that start the words, all of them. So S here, O here, H here, C here, A here, H here, T here, O here, A. Okay, you note down the sentence so that it will be easy for you to remember. Just note down the sentence, okay? Okay, let's take up an example. Let's take up an example. We are given a right angle triangle. We are given a right angle triangle XYZ. It looks like this: X, Y, Z. The value for XY is 3 centimeter. The value for YZ is 4 centimeter. The value for XZ is 5 centimeter. This is an example, okay? This is for your better understanding of the trigonometric ratios. And you should always check 3, 4, 5 whether they follow the Pythagorean triplet rule. That means if I square this and if I square this and add them, do we get the square of this number right here? Let's see, 3 square plus 4 square, how much is it? 9 plus 16, which is 25. What about the square of the remaining side? 5 square is 25. It's the same, right? So you cannot take any number like 6, 7, and 8 here. If I take any number, then this angle right here, it won't be the right angle triangle. So we took a right angle triangle in which the sides are 3, 4, and 5. Question asks find first three first three trigonometric ratios of angle x. So it specifically says which angle should I take in order to find out the trigonometric ratios. It says angle x, right? So we're taking the angle x as theta. Let's take the angle x as theta because the question says angle x. What will be the sine theta? The formula for sine theta. The sine theta is what's the formula? According to some of her, it will be opposite by hypotenuse, right? So first of all, you need to determine which one is the opposite, which one is the adjacent, which one is the hypotenuse. Hypotenuse, we already know it's the opposite of the right angle. The longest one, this is the hypotenuse. No need to determine this. We already know. What about the opposite and adjacent based on the angle that you are taking? We are taking angle x, right? That means the opposite is this one. YZ is the opposite. So this 4 centimeter right here, this is the opposite with respect to angle theta. And with respect to angle theta, this is the adjacent. So we will write adjacent here. 5 centimeter is what now? Hypotenuse. How to find out sine theta then? The formula is just look here. As it says, sum of her S represents sine, of represents the O that is starting, it represents the opposite. It's SOH, opposite divided by hypotenuse. So we will have opposite by hypotenuse. What's the opposite side? With respect to angle theta, opposite side is YZ. Which one is the hypotenuse? Hypotenuse is XZ. Just put in the values, okay? YZ is 4, XZ is 5. That's it. You just can keep like this as 4 by 5. No need to do further calculation. What about the cos theta? The question says first three trigonometric ratio. That means sine theta, cos theta, and tan theta. What about cos theta? In cos theta, we have children are having CAH. Children is cos, A is adjacent, H is hypotenuse. So cos theta, it will be adjacent by hypotenuse. So according to the right angle triangle, adjacent side is 3, hypotenuse is, wait, let me just write the names first. Adjacent side is XY, hypotenuse is YZ. So put in the value 3 divided by 5. The last one, third one actually. So tan theta is trouble over algebra, remember? TOA. Tan theta is what? Opposite divided by adjacent. So we will write the formula is opposite by adjacent. Opposite is YZ. Adjacent is what now? According to the question, adjacent is XY. Put in the value 4 divided by 3. So just keep them as, just copy this one example in order to understand just the basics of trigonometry. Okay. Okay, let us take one more example for better understanding. We will take one more example, which could be a question in your exercise 10.2 also. We'll take one more example and then we will move on to how to find out the trigonometric ratios if specific angles are given. Okay, I'm rubbing them off. Okay, I'm taking the same right angle triangle. I will shift the angle theta. So another second example that I want to do, let's put this one above here. Another example that I want to do is only two of the sides of the triangle are given. This is a right angle triangle, so you have to note down that the Pythagoras theorem still applies. Let's say this is given as 5, this is given as 13 in terms of centimeter, okay? Question wants us to find out the trigonometric ratios of angle Z. So for the triangle, let's say the question says for the triangle, find the trigonometric ratios of sine theta, cos theta, tan theta, where theta is equal to angle Z. If this angle Z is the angle theta, what we have to do is we have to find out sine theta, cos theta, and tan theta. I'm just doing the first three. Okay. Once the knowledge for this sine theta, cos theta, tan theta sinks in, you can do the rest of them. The rest three are very easy. You just have to take reciprocal of sine, cos, and tan. Just understand which ones are the reciprocals, and the remaining three are easy peasy. Understand the just one, two, three. So if angle Z is the angle theta, let's name it angle Z is angle theta. So then find out which one is the opposite, adjacent, and hypotenuse. Hypotenuse is fixed. It's still the one with the longest side. The longest side is the hypotenuse. So this is the hypotenuse. If this is angle theta, what is the opposite? Opposite will be xy. What is opposite to angle Z? That will be the opposite. Xy is the opposite. YZ is the adjacent. What is next to angle theta? That's the adjacent. One issue here, if I want to find out sine theta, for sine theta, the formula is sum of her SOH. Cos theta is are some of her children are having, right? So you have to remember the 9 words. There are just 9 of them. Some of her children are having trouble over algebra. Some of her is the sine part. Children are having is the cos part. Trouble over algebra. That's the tan theta part. So if I want to find out sine theta and tan theta, there is opposite side involved. That means we need to find out what is the opposite side, right? We're given the hypotenuse and adjacent, but opposite is not given there. You have to find out opposite by using the Pythagoras theorem. So when coming to the solution of this example that I'm giving, this is not from your textbook. There is similar question in textbook, but I'm doing a different one. So by Pythagoras theorem, if you apply Pythagoras theorem, what does the Pythagoras theorem say? Hypotenuse square is equal to sum of adjacent side square and opposite side square. That is xz square is equal to xy square plus yz square. Which one do we want to find out? Xy, which is the opposite. If I want to find out the xy square, then bring the yz square to the other side. Xz square minus yz square is equal to xy square. Put in the value, xz is 13 square, yz is 5 square. This is equal to xy square. 169 minus 25 is equal to xy square. 144 is equal to xy square. 144 is 12 square. You cancel the squares out. So finally the value of xy is how much? 12. So the opposite side, what's the length now? It's 12 centimeters. Once we know all the sides, then it's easy to find out sine theta, cos theta, and tan theta, right? So I'm rubbing this off. If you have already copied, then it's fine. If not, I'm rubbing this off. I'm rubbing off what is the opposite side also. I have written opposite, hypotenuse, and adjacent for you. And this will be your homework. This will be your homework, how to find out sine theta, cos theta, and tan theta. This won't be in your textbook. This won't be in any of the guidebooks. This is just from my imagination. Okay, you try to do this yourself. Just take a screenshot, okay? Just take a screenshot and then try to do it yourself. Okay, moving on. Any questions so far? Anything? Anything that I need to explain? Anything that I need to explain? Nothing? So we are good then. Okay, see, if we assign particular value, we're still taking a right angle triangle, A, putting on other side. So I've got a right angle triangle here, A, B, C. So this is the angle theta that I'm taking. If we assign specific value here, if we put angle theta as particular specific value, the specific value that you are going to learn are 0 degree, 30 degree, 45, 60, and 90. The middle three, we will understand it later on. The last two, the first and the last, we will try to understand it right now. So the topic is trigonometric ratios of 0 degree and 90 degree. Now what we are doing is in the triangle ABC, right, and triangle ABC that I'm taking here, I'm taking the angle B as the right angle. and I'm taking angle, this angle C as angle theta. So the opposite side will be obviously AB. This is the opposite side. The adjacent side will be the BC. This is the opposite side right here. So just mention them down there so that we don't get confused in the in middle in between the lecture. Okay. Any issue? Please turning on the microphone. So when will this be 0 degree? What does a 0 degree look like? 90 degree look like this, right? Okay, so perpendicular it looks like this. 0 degree it will look like this. 1 degree it will be absolutely small, very small angle right there. But if we take 0 degree, what we are going to have is we will have, look, in order to make an angle, we need two lines. This space right here is called the angle, isn't it? If the angle decreases, it will look like this. This angle right here is smaller. This angle right here is smaller compared to this angle. If you reduce a little further, it will look like this. If you make it 0, if you make the angle between these two lines right here to be 0, then what we are going to obtain is these two lines here, they will be on top of each other. I'm going to draw one of the line in blue. The other line, I'm going to draw it in red. In this situation, when the blue and red are on top of each other, the angle theta is how much? 0 degree. So imagine in this triangle, okay, these are not necessary anymore. What you need to understand is when the angle is 0 degree, the lines that make the angle, they will be on top of each other. So imagine this angle theta right here. You keep this CB fixed. What are the lines that make the angle theta? CB and AC, right? I'm keeping the CB fixed. I'm keeping it fixed. I'm just drawing a red line over it. I'm keeping the red stuff fixed, but the blue one, I'm reducing the angle. I'm reducing the angle. If I reduce the angle slightly, what happened to the opposite side? Look, the opposite side is shorter compared to the previous one. If I reduce the angle further, the opposite side is little shorter. And then if the angle theta is finally 0 degree, what will happen? This CA line, it will be on top of this line CB. So in that case, when theta is equal to 0, do we have any opposite? No. If you don't understand, let me repeat. This angle theta is made up of AC and BC. If I reduce this angle theta by keeping this CB fixed, reduce the angle, what happened to the opposite side? Opposite side is only this much. Reduce it a little further, opposite side will be this much only. If you reduce it further, the opposite side is again reduced. If you made this angle theta into 0, finally what will happen is the opposite side it vanishes. If the opposite side vanishes, what happened? The opposite side vanishes, the value of opposite side. What's the opposite side that I'm writing here? AB. When theta is 0, the opposite side it vanishes. The opposite side is AB. The AB vanishes. That means AB will be how much? 0. What's the value of sine theta? Formula for sine theta. Instead of theta, I'm taking the angle theta is how much? 0. So don't write sine theta anymore if I write sine 0 degree. Formula for sine 0 is what? SOH, opposite by hypotenuse. Where is the opposite? AB. Hypotenuse is what? AC. The opposite side has turned into how much? 0, right? So if the numerator is 0, 0 divided by some number, it will be 0. So the value of sine 0 degree is how much? 0. What about cos? For cos 0 degree, what will happen? The formula is adjacent by hypotenuse. Okay, look. When the angle theta is 0 degree, what turns into 0? And look, I'm rubbing off the middle part. What turns into 0? This AB keep reducing until when the angle theta is 0, the opposite side it vanishes. But when the AB vanishes, what happens is the hypotenuse and adjacent, they are on top of each other. If they are on top of each other, hypotenuse is equal to what? Adjacent. So hypotenuse is equal to adjacent. Remember, for the formula of cos 0, we have got adjacent by hypotenuse. When the angle is 0 degree, adjacent and hypotenuse, they are equal. If you divide two equal number, 2 by 2 or 3 by 3, we get the same value, right? We get 1. If you divide 5 by 5 also, we will get 1 after cancellation. So adjacent and hypotenuse are equal. So when we divide them, the value that we are able to obtain is, we will get how much? We will get 1. What about tan 0? The formula for tan is what? Trouble over algebra. So we have got opposite divided by adjacent. How much is opposite? Opposite is it vanishes. That means opposite is equal to 0. Tan 0 degree will be, the numerator is 0, 0 divided by any number. So we will get 0 divided by adjacent, 0 divided by adjacent, which will be 0. Once you know sine, cos, and tan, the others are very easy. Others you have to take reciprocal. We will learn that later on. For today, you copy this. This part is absolutely important. Sorry, I cannot take it out. So this part is important right here. I'm going to enclose it with red. When the theta becomes 0, the opposite side it vanishes, turns into 0. You have to understand how is that. And when the opposite side vanishes, what happens is hypotenuse is equal to adjacent. Okay, if it was a live class, I can show you. I mean, if it's a physical class, then I can show you with two sticks. Very simple. So hypotenuse is equal to adjacent, opposite side is 0. By using these 1, 2 values, we have found out sine 0, cos 0, tan 0. You can find out the others also. You can find out the cosec theta. Cosec theta, instead of theta, we will put 0 degree. Cosec is the reciprocal of sine. That means we will write the value of sine 0 is 1. Sine 0 is 0. We will write it below. 1 by 0. Reciprocal means 1 by any value, right? What about the sec 0? Sec is the reciprocal of cos. So we will write 1 by 1. What about tan 0? Tan 0 degree will also be 1. No, sorry, should be cot. Cot 0 degree will be reciprocal of 10. The value of 10 is 0, so we will have 1 by 0. Any number divided by 0 is infinity. 1 by 1 is 1. 1 by 0 is again infinity. So you write this down. 1, 2, 3, 4, 5, 6 formulas. Okay, you copy along with the formula, along with the diagram right here. You have to copy what you need to understand is this value, the final ones. It is not absolutely relevant how we obtain this, but it's good for your knowledge. What you need to understand is what's the value of sine 0, cos 0, tan 0. So that stuff you need to understand properly. Okay, with this, let's finish for today. Okay, we will take up, we will try to understand what is the value of sine, cos, tan when the 0 degree, 0 degree, 0 degree. If the 0 degree here, if this angle is replaced with 45 degree or 30 degree or 60 degree, we will try to understand what's the value of sine 30, cos 30, tan 45, sine 45. Those stuffs we'll try to understand tomorrow and day after tomorrow. 45, 30, 60, there will be a little long, okay? And it's also asked very frequently in your board exam. So this 0 degree, 90 degree, not much important, but the 30 degree, 45, 60, they are very important.